Hey everyone, in this video we're going to be going over predicting products for a couple different types of chemical reactions. Specifically, we're going to be looking at combustion reactions, decomposition reactions, and synthesis reactions. So to start, I want to point your attention to your reference sheet. On your reference sheet on page 6, you have this document that says Guidelines for Predicting the Products of Selected Types of Chemical Reactions. A couple things I want you to know about this reference sheet. One is you can always use it. It's always here for you. Use it for all of your practice, for your assessments, whatever. Okay, it breaks down the 5 types of chemical reactions. Okay, and we're going to spend most of our time focusing on the first type for each of them. That's really going to be this. And combustion only has 1. So we're really going to focus on just the binary compounds. The other thing that I want you to notice is there is a key up here that M stands for metal and NM stands for nonmetal. Remember that we can identify elements as metals or nonmetals based on where they live on the periodic table in relation to the stair step. Okay, we also need to know that we kind of apply the metal to the scenario. So, I'm still in my highlighter. So whenever you are using one of these types of reactions, you might see with a metal or a non-metal in there, you're going to apply the metal. So that means you're going to have to use its charge as well as just its symbol. All right, so let's jump in. Whenever we are predicting products, we are going to see just the reactants of our equation, and the product side is completely blank. So there are 3 steps to any problem that look like this. Number 1, you need to classify. So you first need to figure out what type of reaction you have. So synthesis, decomposition, single replacement, and so on. So you need to be able to identify the type of reaction from just the reactants. Then you're going to use the rules that you're going to learn from these videos to predict the products. You need to make sure that you're writing formulas properly. So you are going to be using the formula writing technique that we have already learned to make sure to write proper neutral chemical formulas. And then finally, always last, we balance. So balancing is always the last step. We follow the procedure that we have been using to balance the reaction. That is always the last step. So we first classify, second predict, and last we always balance. So let's start with the simplest type of reaction prediction, combustion. Combustion is when we have something burning in oxygen. And for our purposes, we're going to focus combustion being just when a hydrocarbon burns in oxygen. So if you want on your reference sheet, go ahead and write that little kind of generic formula for a hydrocarbon on there, right? And then you can remind yourself that oxygen is O2. So a hydrocarbon generally has carbon and hydrogen. Sometimes it might have oxygen on it. So that's okay if that's the case. It still works this way. But when the hydrocarbon burns in oxygen, the carbon is going to get to hang out with the oxygen on the other side with carbon dioxide. And so is the hydrogen, right? The analogy was everybody loves oxygen. Carbon is now with oxygen, and so is the hydrogen. So the products are always the same. Always. And this is on your reference sheet, folks. This is exactly what it says in this box up here. The hydrocarbon plus oxygen always produces carbon dioxide and water. So if you tell me that a reaction is a combustion reaction, you better tell me that the products are carbon dioxide and water. So let's do an example. I have listed out my 3 steps on all of my example slides so that we can make sure that we are following those properly. So C6H12 plus O2. This is a hydrocarbon plus oxygen. Okay, so that means this is a combustion reaction. So that's my step 1, classify. Based on my reference table and what we just talked about, my predict step is going to tell me that my products need to be carbon dioxide and water. Okay, so I'm going to rewrite that here, rewrite the whole thing in a better setup to be able to balance. So I have my lines for the coefficients out front, and now I can start to balance. So I'll do that in a different color here. Carbon, hydrogen, oxygen. 6 carbons, 12 hydrogens, and 2 oxygens on the left side in my reactants. 1 carbon, 2 hydrogens, and 3 oxygens on the right side in the products of the reaction. So I'll start with my carbons. If I have 6 of these, that'll give me 6 carbons, but then that ups my oxygens to 13. I'm going to put a 6 here to match the 12 hydrogens on the left. So 6 plus 12 is a total of 18. So to match 18, I'm going to go ahead and put a 9 on that line. 9 O2s will give me 18 oxygens so that this reaction is balanced. So those are my 3 steps. I decided it was a combustion reaction, used my reference table to tell me that the products are CO2 and H2O, and then I balanced. So there we go. That's the same for all combustion reactions. Moving on to decomposition. Decomposition reactions are when we have a compound break apart, right? Decompose literally means to break down or to break apart. So we're going to focus again on the binary compounds. So we can see this is the first part of our list on the reference sheet. Okay, so when we have a binary compound, so one that's 2 parts, right, just 2 elements, breaking down into the individual elements, we have to be very careful. There are 7 elements that when they are by themselves as elements are diatomic. They come in pairs, right? So they will be H2, O2, N2, Cl2, Br2, I2, and F2. Whenever you have those elements as products here, and you'll see it also as reactants and synthesis reactions, they come in these little pairs, okay? They're diatomic. So I like to remember these by saying this word, Honkelbrief, and I like to call it the Honkelbrief Club. And that's how I remember the 7 diatomic elements: Honkelbrief, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine. Okay, so this is where things get tricky. When there are elements by themselves that are one of those 7, they have to have their little buddy. They come in pairs. So let's try some examples. Okay, so step 1 for every one of these problems is going to be to classify. So both of these are decomposition. I'm giving you that context in this case. You may not have it in the future. If you don't have it in the future, we can think about the fact that the only thing that can happen with one compound on the left side of a reaction is it has to break down. That's its only option. So now I can predict. So I classified as decomposition. Well, my decomposition reaction says AB plus is A plus B. But we got to watch out for diatomics. So this number 1, my 2 elements are mercury and oxygen. However, oxygen is part of that Honkelbrief club, so it's got to be H2. Right? So that's one of those rules of nature we have to follow, and that's why we have to ultimately balance reactions. If we didn't have things like that, we didn't have rules of nature like that, we wouldn't even have balancing reactions as a concept to learn about because everything would always be perfectly balanced, and that's just not the case. So after I predicted this, I can go ahead and balance the reaction. So I have one mercury, two oxygens compared to one oxygen over here. So I need a big 2 on that line, 2 mercury oxides to balance the oxygens, but then I'm also going to need a 2 here. So the way that reaction would look at the end, 2 mercury oxides will break apart to form 2 mercury atoms and 1 oxygen atom. Excuse me, 1 oxygen molecule. All right, second example here, H2O. H2O breaking down is going to break apart into its elements, right? The elements here are hydrogen and oxygen. And then we double check, are they part of the Honkelbrief club? Yes, oxygen and hydrogen are both diatomic. So now I need to go ahead and balance this reaction. Hydrogen and oxygen, both diatomic. So our products are H2 and O2. And now I can balance 2 hydrogens on the left, 2 hydrogens on the right, 1 oxygen on the left, 2 on the right. So I need to fix that. 2 waters then to balance the oxygens, but that makes 4 hydrogens. So I'm going to need 2 hydrogen molecules on the right. So that is my final answer for number 2 there. The last type of reaction that we are going to discuss in this video is synthesis. Synthesis reactions are when we have 2 elements coming together to form a new compound. So this is the exact opposite of decomposition. You can see that the reaction listed here is in fact the inverse, right? So when we're predicting the products for synthesis reactions, we are going to use our understanding of formula writing, okay? And by formula writing, I mean finding charges, right? We're finding the charges from the periodic table, our labeled periodic table, and balancing out those charges to make sure it's a neutral compound. So we are writing ionic formulas for the products of synthesis reactions. So let's do a couple examples. Okay, so again, our 3 steps are always to classify, predict, and then balance. So I've given you the context that these are synthesis reactions. So we don't have that much trouble here classifying. So I can go on to predict, right? If my synthesis reaction, is A plus B makes AB, we're going to use that as our guide. So number 1, H plus Cl, right? 2 elements by themselves, only option is for them to come together, synthesize a compound. So I need to write the formula for what H and Cl are going to do together. Well, hydrogen lives in group 1, so it has a +1 charge. Chlorine lives in group 7, or group 17A, so it has a -1 charge. So when I write that formula, okay, it's going to look like this, HCl. So that's my predict. I wrote the formula for how hydrogen and chlorine would come together. Doesn't matter that they're diatomic and there's 2 of them over here. We're writing the formula for hydrogen and chlorine together. Hydrogen chloride, if you would. This would actually be hydrochloric acid. So now I'm going to rewrite it so that I have a little bit of a cleaner space to balance it. And it looks like a hydrogen molecule coming together with a chlorine molecule will make 2 HCl's, 2 hydrogens here I need 2 over here, 2 chlorines over here, I need 2 over here. So there we go. Moving on to the second example. Calcium plus oxygen, okay? I could even write this in words, right? What's the name of the compound that would form from those things? It would be calcium oxide, right? So now I need to write the formula for calcium oxide. So calcium lives in group 2, it has a +2 charge. Oxygen lives in group 6, it has a -2 charge. So those are going to even each other out in a 1-to-1 ratio. So my product here is calcium oxide CaO. So now I can go ahead and write this reaction and make sure it's balanced. I'll use a different color. So 1 calcium, 2 oxygens, 1 oxygen on this side. So I'm going to need a 2 over here. I need 2 calcium oxides to balance out the oxygens, but that does throw off the calcium, so I'm going to have to balance that by putting a 2 in front of the calcium. So 2 calciums plus 1 oxygen molecule will make 2 calcium oxide units. All right, so always, always, always follow these 3 steps: classify, then predict using the rules we just talked about, and then balance. Essentially, in this predict stage, right, we're following the laws of nature, right, with diatomic elements or the way that elements will combine and their ionic formulas. And then when we're balancing, we're enforcing the law of conservation of matter. So we follow those steps follow those laws in different steps. So make sure that you're conscious of that as you're working through these problems.